All right, let's get right into it. We all have those cloud dashboards we love, you know? The ones with the pretty graphs that are supposed to tell us everything's okay. But what happens when the real problems are hiding in the blind spots, in the data we're not looking at? Well, today we're going to jump into the trenches and look at 3 war stories that expose some of those critical hidden gaps in cloud observability.
Just imagine this for a second. It's 3 in the morning and that awful pager alert rips you out of a deep sleep. You drag yourself to the computer, you pull up the dashboard, and the metrics look fine. Everything's green. But you know deep down that the system is failing. It's that horrible sinking feeling when you realize your tools are lying to you. You're flying completely blind, and every second counts.
So our first story is a real head-scratcher. We're calling it the phantom load. It was one of those situations where the system just seemed haunted, like it was attacking itself with this frantic, chaotic energy. And the weirdest part? The culprit turned out to be the very automation that was supposed to be keeping things stable.
So what the on-call team was seeing was just chaos. Their GCP compute instances were spinning up and then immediately terminating, over and over and over again. Now, this wasn't just making the system unstable, it was literally burning money with every single cycle. The dashboards, they showed the thrashing perfectly clear, but they gave 0 clues as to why it was happening. It was a total mystery.
And this right here, this is the core of the blind spot. On the left, that's what they had, a simple chart showing the what, the instance count going completely haywire. But what they really needed is there on the right, a simple log entry explaining the why. The autoscaler was basically a black box, making these huge decisions without ever explaining its logic. Turns out, the fix was almost laughably simple. The team found a feature in Google Cloud that logs the actual reasoning behind every single autoscaler decision. All they had to do was flip a switch to turn it on, and bam! Suddenly, they could see, in plain English, why the system was scaling up and down, and a simple misconfiguration in their scaling policy just jumped right off the page.
So, let's wrap up this first case. The blind spot? Having 0 insight into automated decisions. The fix? Just enabling some detailed logs. And the lesson here is so important for any automated system. You have got to log the why, not just the what.
All right, let's move on to our second story. This one takes us into the crazy world of containers with Google Kubernetes Engine, or GKE. This is the classic case of the noisy neighbor, where just one bad application running on a shared machine can wreak havoc on everything else around it.
Now, this was another one of those situations that just makes no sense at first. A really critical service was failing. Requests were timing out all over the place. But when the team looked at the metrics for that service's container, its pod, everything looked great. CPU was low, memory was stable. The service itself was pretty much screaming, "Hey, it's not me."
And this slide really nails the blind spot. See, they were zoomed in, looking at the metrics for just a single pod, which looked fine. But in a shared environment like Kubernetes, you have to see the whole picture. The problem wasn't their pod, it was another one, a noisy neighbor on the exact same physical machine, or node, that was gobbling up all the resources and starving their critical service. And here's how they found it. The solution was to enrich their application logs with all this useful Kubernetes metadata, things like the pod name, and this is the crucial part, the node name. By adding that little piece of context, they could finally run a query to see every single application running on that one troubled node. And just like that, the resource hog was obvious. So the takeaway from this one is crystal clear. The blind spot was not being able to see resource contention on a shared machine. The fix was adding that environmental context to all their logs. And the lesson is simple. In these shared, containerized worlds, context is absolutely everything.
Okay, our final story is, well, it's maybe the most insidious of them all. It's not about a big, loud crash. It's about a slow, creeping failure that quietly poisons the system over time. I like to call this one the silent leak. What the team was seeing was that every few days, their application would just fall over, complaining that it couldn't connect to the database anymore. A quick restart would fix it, but only for a little while, and then the problem would always come back. This is the classic signature of a resource leak. In this case, database connections were being opened but never, ever closed.
The default observability tools just weren't cutting it. Yeah, their tracing showed that database calls were getting slower and slower, but that was just the symptom, not the root cause. The real blind spot was buried deep in the code. The default tools couldn't show them the difference between the time spent waiting for a connection versus the time spent actually running a query.
So how'd they finally catch it?
They had to go beyond the defaults. As you can see here, they used Google Cloud Trace to add their own custom instrumentation. Basically, they started a little timer the second a connection was acquired and only ended that timer after the connection was properly released. And suddenly, in the trace visualization, the problem was crystal clear. You could literally see connections being acquired, but the release part was just missing. The leak was finally found.
This last case study leaves us with a really powerful lesson. The blind spot was that this code-level mess was totally invisible. The fix was getting surgical with custom tracing. And the big lesson is that you have to instrument your most critical code paths yourself. You just can't assume the out-of-the-box stuff is going to show you everything you need to see.
So after going through all that pain, after surviving these 3 incidents, we can't just move on, right? We need a playbook, a simple set of rules to make sure we never get caught by these blind spots again. Let's boil down all these lessons into some advice you can actually use. Here it is, your 3 observability must-haves. Number 1, log the why. Force your automation to explain itself. 2, add context everywhere. Knowing where something happened is just as important as knowing what happened. And 3, instrument your critical paths. Go deeper than the defaults to see what your code is really doing under pressure.
And that really brings us to the final, most important question. These stories, they aren't just about Google Cloud. They're about a whole mindset. So I'm going to leave you with this to chew on. Based on what we've talked about today, what invisible problem, what critical blind spot do you think is hiding in your cloud at this very moment?